Chris is a Boston engineer who was born with one arm. He grew up exposed to different prosthetic technologies, but the arm-skin interface of current sockets makes you choose between comfort and functionality.
It would get hot, it would swell, and then it would really just fill up the socket, and it'd be so uncomfortable. I always have to put talcum powder on it, and it sucks.
Soft sockets allow the prosthesis to shift, while stable sockets cause pain from poorly distributed pressure. This discourages physical activity, resulting in muscles weakening over time.
And as a result, I didn't use it for anything except for holding stuff.
In order to make prostheses useful tools, socket technology should focus on providing comfortable, functional connections with the body, rather than just looking like a natural limb.
To get there, socket research will need to move away from slow, incremental medical research and into the maker movement, where innovative ideas can come through rapid recombination of novel solutions. We've tried attacking this problem by combining technologies from multiple fields. By the end, our team designed a socket and harness combination that lets Chris attach any specialized prosthetic he wants.
The first step was exploring potentially useful materials from all kinds of fields. Inexpensive products containing specialized materials helped us to start testing. We found that material selection is crucial to the socket design because while soft materials are inherently more comfortable, they do have a tendency to slip on the skin, causing much more discomfort in the long run.
Using the popular Kinect hardware, a software program called Skinect can create a 3D model of any object. For under $150, we were able to get an accurate digital model of Chris's arm. Additionally, we used a cheap plaster and gauze wrap to create a physical mold of his arm to help with prototyping.
Chris mentioned early on that clamping style sockets appealed to him as they utilize the strength of the bone without requiring surgery. We measured comfortable clamping depths of his arm. With these dimensions, we explored various available fabrication techniques. Starting with sketch models made out of everyday materials like cardboard, we then went through 5 iterations of our actual socket, continually evolving based on Chris's feedback.
Chris mentioned that he'd rather have a sturdy and reliable socket than a purely aesthetic one. It needs strong attachment points to both the arm tool and the harness.
A spandex shirt served as a simple base upon which we sewed both elastic and rigid straps to provide a strong yet flexible harness for active wear. The elastic straps provide constant tension to keep the socket in place, and the rigid straps are backup supports for cases of extreme loading. To keep the design modular, the harness straps attach with quick-release buckles to the socket, and leg straps can be attached for overhead loading.
Chris was a great sport and an inspiration, allowing us to try ideas that sounded strange or looked weird. He encouraged the use of new tools and experimental methods for the sake of rapid iteration and quick development, as well as bringing in knowledge from all sorts of other fields. We briefly considered many unexplored routes, ending with a design that brings prosthetic sockets out of proprietary research and into the democratized hackerspace. We've got a solution. Can you make a better one?